Corporate finance, practice problem using Excel, bond coupon rate, current yield, and yield to maturity calculations. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that there are 4 tabs down below. The 2 green tabs are the 2 example tabs, in essence being the answer key. The 2 blue tabs are going to be the tabs that we'll work through the practice problems with, starting with practice tab 1. We're going to have the information on the left, calculations on the right. We have the bonds outstanding, par value, the 1,000, the annual interest payment, 90, market price, 800, years to maturity, 10. We'll calculate the coupon rate, the current yield, and then we'll take a look at the yield to maturity, doing an approximate calculation and a more exact calculation there, doing that a few different ways. Coupon rate, very basic calculation. We're just going to be taking the annual interest payment, that being the $90. We're going to be comparing that to the par value or face amount, that being the 1,000, and that's going to give us the coupon rate. It's simply dividing that out. That is the 90 divided by 1,000. Making that cell a percent by going to the number group, percentifying it, underline under the 1,000, font group, put in a line underneath that 1,000, otherwise known as the underline. Then we'll calculate the current yield, kind of a simplified performance type of calculation. To do that, we'll take the annual interest payment of the $90, compare that to the market price, what we assume would be paid for. So we got the market price, which we're saying is the $800. So comparing the price to basically the annual kind of return on it. Font group underline, and that's going to give us the current yield. The current yield equals the 90 divided by the 800. Let's make that a percent. Go into the numbers group, making it a percent, adding a couple decimals. We're at the 11.25. Now we're going to calculate the yield to maturity. We'll do it a couple different ways. We'll have a couple formulas we'll use down below. But let's first just do the goal-seek type of calculation. And so what we'll do here is we'll imagine that we knew the yield to maturity and we're trying to figure out the market price. And then we'll use basically the goal-seek feature to back in, because most people probably understand how to calculate the market price more easily than the rate, the yield to maturity rate. And then we'll do it with the rate function, and then we'll do it with a couple different calculations as well, which will be more of approximations. Okay, so normally, if I knew the rate to maturity, we would calculate the present value of the interest payments, which is an annuity calculation, and the present value of the par value or the face value of it, and that would give us the market price. Now in this case we know the market price, it's the $800. We don't know the rate. So what I'm going to do is start out here and pretend we knew the rate at 10%. We'll start off with 10%, we'll do the calculation with 10%, then we'll simply adjust this rate using Excel to the rate we need to get it to make the end result the $800 that we know it should be. Basically kind of thinking of the algebraic idea of solving for the one unknown, but instead of solving for it by adjusting it algebraically, simply using goal-seek brute force computer power to do it, which is neat. That's powerful computer power. So we're going to say present value, shift 9. We're going to take the rate down here, the 10%, the made-up rate, comma, number of periods is going to be 10. We have 10 periods, comma, and then the payment is going to be the $90, the $90. And so that's going to be, and I'm going to do this a little bit more quickly because we have done these calculations prior when we calculated bond calculations. So you could take a look at that section if you want to go into this in a much more detail, as well as calculate it with different present value calculations using a formula or tables. So you can go back to our present value section if you want to just practice in on that as well. So now we'll do the present value of the face amount here, the face amount. So this is present value of one formula, present value, shift 9, the rate's the 10%, comma, the number of periods we're going to say is still the 10 down below, comma, comma, because it's not an annuity this time, but present value of 1, face amount is that 1,000 that we're bringing back, and it failed. Something has failed here. So I put a period instead of a comma, comma. So there we have it. I think that's right then. There we have it. And then if we add those up, that would normally give us the market price. I'm going to put an underline here by going to the font group and underline. Now we know this end result needs to be $800. I would like to get there by changing this percentage, which I could do by simply manually adjusting it and seeing Excel changes it automatically. That's pretty close. It's getting closer, but I'm going to do that using GoalSeek. So GoalSeek will just do that with brute force, trial and error method, changing the unknown until it makes the thing what it needs to be to make it right. So let's do that. We're going to then go to the data up here. Then we're going to go to the forecasts, what if analysis. We're going to do an analysis about what if stuff. And then we're going to say that we want to change this cell to be what we know it should be, which is the market price of $800. And we want it to get there by changing the rate, which is this 11%. Change that 11% to whatever it needs to be to make the end result, the market price, what we know it should be, $800. Okay, so okay, and then it does it for us, just like that, like a snap of the fingers. And there's the 12.63. So there we have it. Now we can also do that with a rate calculation. So we could do this in Excel. You might say, why do I use GoalSeek? Isn't there another function in Excel that we could use? We could. I think a lot of times this is more intuitive for many people to know, but there's a rate function too. So we can say, all right, let's pick up the rate. So I'm going to say this equals the rate, shift 9. Then we got the number of periods, which is 10, comma. The payment then is going to be the 90, comma. And I think the payment needs to be negative to get it to get this right. This is a little bit tricky. That's why these get a little bit tricky. You've got to put some negatives in here to make it right. And then we got to say, comma, the present value is going to be the market price of the 800, comma, and the future value is going to be the 1000, comma, and then we're going to say we want to end it with this first one, end of the period here. I'm going to double click on that, and that puts a 0, and I think that's all we need. So let's say enter, and it didn't like it. It didn't like it. Hold on a second. That's because this future value right there needs to be negative on the future value, and enter. All right, there we have it. So double clicking on it again, one more check, rate. We got the number of periods. We've got the payment here on B3, which is the 90. Then we have the present value, which is the price. And then we have negative of the future value, which is the cost at the end, the 1000, and then the 0. Now, even if you were to use this rate function, I would still then recalculate the market price, doing your calculations up top using that rate, so that you then get to the market price you should know it to be, which is the $800 as a double check. All right, but now we're going to do it again, this time with a formula. Now, this is an approximation of the formula. We're going to alter the numerator a little bit first, which is a little bit more accurate. Oftentimes, if you look up the approximation for the yield to maturity, it'll be divided by 2, but we'll adjust that a little bit, and you'll see the difference here. It's a little bit more accurate, it seems, with this little tweak. So we're going to then do this calculation. This is an estimate type of calculation that you can do without the function. So I'm going to basically put this up top. This is kind of a complicated formula due to all the divisions. It's not too bad, but you can see we have a lot of fractions involved in it. So I'm going to try to break this out in a table type of format, which can look kind of ugly, but it should be okay. So I'm going to say that C is the coupon or interest payment. So that's going to be up top. I'm going to put that in the column M. That's the $90. And then we're going to have the par value. I'm going to bring this into the inside column now, calculating this F minus P, which is going to be the face value minus the price. So the face value was the 1,000, we're going to say, 1,000. And then the price, we said, and I'm going to call that market price for our purposes. Market price was equal to the $800. So I'm going to take that difference. I'm just going to call it a subtotal. You could call it par value minus market price. This is going to be equal to the 1,000 minus the 800. So now we've got this F minus P over N, which is going to be the number of years. So I'm going to call it years to maturity. So years to maturity, which we said was 10, I believe, wasn't it? It was. I was right. My memory is like a trap made of steel stuff can't get out of there, but stuff can get in there somehow, even though it's trapped up in steel. So we're going to say there we have those two, and then that's going to give us the subtotal. The subtotal again, I'll put this in the outer column. So that's going to be the 200 divided by 10. So that brings us to this component right there. And then we're going to say add up this numerator, and that's going to give us the total of the numerator. I'll underline here, font group and underline. Let's sum this up equals the sum. So that's going to be the numerator. Let's just call it that, numerator. And I'd actually rather have it out here more. I'm going to put it out in the outer column. The numerator is in the outer column. That's where we want the end point of this cell. And then I've got the bottom part, which we're going to tweak a little bit. We're going to do it a little bit of an alteration here. So we're going to take the market price, and I'm going to put that in column L, which is going to be, once again, the 800. I'll just pick it up from up here, and we're going to multiply that times 0.6. I'm going to say number group, and this is where the change happens. We're not just adding it up and divided by 2, but we're taking the market price times 0.6, multiplying that out, font group, underline, multiply this out, and so there we have that. And then we're going to take the par value, so I'm going to say this is equal to the par value, and that's going to be the 1000, and we're going to multiply that times 0.4, so it adds up to 100%. I'm going to make that a percent. Numbers group, percentifying that. Then we're going to go to the font group and underline, multiply that out to 1000 times the 0.4, and then we'll take those two and we'll add them up. So I'm going to say font group and underline, pull that to the outer column equals the SUM, and sum that up, and that's going to give us our approximate yield to maturity, summing up, not summing up, equals the 110 divided by the 880, making that a percent. Numbers group, percent, adding a couple decimals. So that's the approximate formula here. You can see it's close, it's not exact. Excel would obviously be more exact. Now, what we did here is we switched this up, the 800 times the 60, the 1000 times the 40, instead of the face amount and the price divided by 2. So we could do this other method. It's not quite the same here. It's a little further off, but that's another approximation you could do with a calculation that you might see if you're working this in like a book problem. Obviously, working this in Excel would be the best way to go typically. So I'm going to copy the whole top of the formula, and then we'll redo this bottom piece right here in the alternative format just to see that alternative format. All right, so the top one, we're going to say S in column S is just going to be the same, 90, and then we had the par value. The par value was 1000, and then we compared that to the market price. The market price, let's make this cell a little bit larger because it's kind of blocking some of our stuff. I'll make this whole thing a little bit smaller, move it over here a bit. All right, some little minor adjustments. And then underline, font group, and underline. That's going to give us our subtote, and that's going to be equal to the 1000 minus the 800. Then we have the maturity in years, or years to maturity, was the 10. Let's underline that. Font group and underline. That's going to give us another subtote. Subtote is going to be equal to the 200 divided by 10, which is now 20. Let's underline that, go to the font group and underline, and that's going to give us our numerator, the top number, the num. So our num is going to be then the 90 plus the 20, or the 110. Now the denominator is where the new stuff happens. Here's where we're getting new things going on. There's new things happening here. So that's going to be then the 800. And then we're going to add that to the par value. The par value here instead, and that's going to be equal to the 1000. So we'll add those two up. So I'm going to sum that up, equals the SUM, and then simply divide that by 2. So I'm going to underline here, font group and underline, and then dividing it by 2, pulling that out to the outside, the 1800 divided by 2. Let's put an underline here, font group and underline, and then pull that to the outside. We now have the 110 divided by 900, make that a percent, numbers group, percentify, a couple decimals, and there we have it there. So it's close. It's not quite the same. This approximation is a bit more approximated towards the actual answer, and the actual amount being the 12.63. Let's do it again. Let's go to practice problem number 2 here, where we can repeat this whole process and with new numbers. Whole process, new numbers being done this time. So now we got the bond outstanding par value 1,000. Annual interest payment is going to be 110, and the market price is 1,300. So it's at a premium this time, issued at a premium. Maturity date in years will be 8. So coupon rate is simply going to be the annual interest payment, which is the 110 this time, compared to the par value, 1,000, underlining that by going to the font group and underline. That's going to give us the coupon rate, which is going to be equal to 110 divided by 1,000. And then we're going to go up top, numbers, and percentify. We'll add a couple decimals. That's 11%. Then we want the current yield, which is kind of our easy approximation, which, remember, when we do the actual calculation for the yield to maturity, that's typically a more dependable number, because it's going to be a more dependable number generally than just the current yield rate that's based on one calculation for basically 1 year. So this is kind of the quicker estimate of a performance calculation. So we're going to take the annual interest payment then, which is going to be the 110, and compare that to the market price, which we said was 1,300. That's going to give us our current yield. This is what has been yield, or what would be yielded. 110, and dividing that out, underline, font group, and underline. And then we're going to go to the font, the numbers, and percentify that, make a couple decimals added on. So there we have that. Then we're going to calculate the yield to maturity, which is probably a more accurate calculation, or something that could be a little bit more dependable when making a decision on. And this time we'll do this a couple different ways. Again, let's first do the goal seek, because normally people are probably pretty used to calculating the market price. Let's pretend we know what the rate is and use it to calculate the market price by guessing a rate, 10%. We're going to guess. And we usually calculate the market price by taking the present value of the interest, and then the present value of the par value, or the maturity value, and then that would give us the market price, which we already know in this case is 1,003. Let's do our calculations. I'll do this fairly quickly. We've seen this in the past. If you want more work on different ways to do the present value calculations, prior section's a place for that. If you want to take a look at bond calculations in more detail, take a look at a prior section where we focus in on bonds a lot. We're going to say negative, present value, shift 9. Rate is going to be that 10%. We just guessed it down there, comma. Number of periods is going to be 8 periods. And then we'll say comma, and the number, and then the payment for an annuity was the 110. So then we'll do it for the present value of 1, negative, present value, shift 9, rate is that 110 we're guessing at, comma. Number of periods is going to be 8, comma, because it's not an annuity this time, but present value of 1, and then picking up that 1,000 and enter. Let's add these up, equals the SUM, the sum of these two guys, and then underlining it, home group, home tab, font group, and underline. Now we know what that number should be. It should be 1,300. We want to get it there by changing the percent, changing that 10%. In other words, we want to say change that 10% to whatever it needs to be to get that number to what it should be, 1,300. So we could do that manually, like 9% changes it and so on, or we can ask Excel to do it using brute force computer power. And we do that by saying, Excel, could you do that for us? Like make that number be 1,300 by changing that percent. And Excel would say, yes, we can. It's going to be up in the data group up top. And then you go to the forecast area, what if analysis, and just use our goal seek feature right here, which is designed to do just that. And then we'll take the cell. We want to take this cell. We want to change it to the value of that 1,300, 1,300, by changing then the percentage cell of that 9%. So change that cell to 1,300 by changing the 9% cell. Okay, and Excel does it just like that, like a finger snapping. That's how easy it is. I would snap my fingers, but I can snap them, but it doesn't sound that loud when I do it usually. I'm not a good snapper. So anyway, we can do it with a rate function too. We can do it with the rate. This equals the rate, shift 9, and then we could take the number of periods, which is going to be 8. I'm sorry, the number of periods, and then the payment. This has to be negative, you'll recall. The payment is going to be 110, comma, the present value, which was the 1,300, comma, future value. I think this has to be negative, picking up the 1,000 on the future value, comma, we're going to make it end of the period as the type, which is a 0, and enter. So there we have it once again done that way. Now let's do the approximation with our formulas down below. Let's do the approximation calculations. You might be asked to do, obviously if you have Excel, then I would do it, one of these ways. But if you're forced to do it with this calculation method, possibly by a textbook, then you can do it this way. So we have a couple ways we can do this calculation. This is the approximate yield to maturity. So we're going to take the annual interest payment. We're going to look at this calculation. I'm going to break this down into a table. And note, this is actually a useful thing to do in practice, to basically be able to break something out algebraically. It's useful to write it down. Obviously, you can write this down into the formula and do it mathematically, algebraically. But oftentimes, it's useful to take something like that and put it into a table. So if you're imagining something long and ugly problem like this, well, these division problems in a table, I would first think, okay, I want the numerator and the denominator ending up on the outer column here. And then every time I have a fraction, I might do another subcategory for the fraction. So we're basically going to imagine the whole numerator is going to be on the outside. And then I'm going to take a look at this f minus p is going to be basically the first calculation that we're going to take a look at. And that's going to be the face value minus the price. And then I'll put the C out here on the outside. So C is what we started with. I'm going to put that here. That's going to be in the outer column. And we're going to add these two top areas up in some point. This is going to be the 110, which was the coupon rate or the interest payments. And then we got the par value. So it's going to be the par. I'll just type it in there. Par value, which is going to be, I'm going to pull this all the way to the inside because I'm going to do this F minus P area now, which is the face minus the price. Par value was the 1,000. Then we'll pick up the market price, and that's going to be equal to then the 1,300, making an underline there by going to the Home tab, going to the font group and underline, drawing a line underneath. It's the line underneath, which is why it's called the underline. And then we'll subtract that out. This is the 1,000 minus the 300, negative 300 then being the amount. Then we've got the maturity. I'm going to say, I'll go all the way over here. Maturity in years is going to be 10. That's going to be 10. We got 10. Actually, it was 8. I'm sorry, 8. 10 was last time. I'm getting these things mixed up. Font group and then underline. I apologize for that. Hope I didn't confuse anyone other than myself. Subtotal. And then we're going to then take the 300 divided by the 8, and that's going to give us the 38. Let's add some decimals, number group, and add a couple decimals there, and then we can add that to the 110. So I'm going to underline it, font group, and underline, and add it to the 110. I'm just going to call this the numerator. Hopefully I spelled that correctly. And so we're going to have to say the numerator, and that's going to then be the 110 plus the 3750 for 73. Let's add a couple decimals over here. We're at the 7250. And then that's going to be the numerator. Then we're going to do that slight alteration down here. So I'm going to take the market price. So I can pick that up top, the market price. I'm going to pull that into column L, which is going to be equal to 1,300. I'm going to multiply that times 60%. This is the alteration. Going to go up top, make that a percent, 0.6. And I'm going to go to the font group and underline it. Multiplying that out, then this is going to be the 1,300 times the 60%. We'll add a couple decimals. And then we're going to say that's going to be the par value. So we'll then take the par value, which is the 1,000 times the 0.4%. 0.4 number, adding a couple decimals, font group, underline, multiplying it out, 1,000 times 0.4. Let's put an underline here, and then we'll put this into the outer column. This is going to be equal to the SUM, the sum. Adding that up, we'll add a couple decimals, do an underline here, font group and underline, and that's going to be our approximate yield to maturity. Approximate yield to maturity, which is going to be equal to then the 7250 divided by that number we just got to, and making that a percent, number group, percentifying it, adding a couple decimals. So note, this one is basically right on this time with our little alteration to this formula. And it's not always right on, but this time it was. Let's do it again, this time with this same method here, which is going to be the face value, the par value, plus the price divided by 2 instead of the 60-40 kind of calculation, and see what we get to then. So the numerator is going to be the same. I'll do this pretty quickly. This is going to be equal to the annual interest payment. We're going to bring that in column S, which is going to be the 110. Then pulling into the inside, I'm just going to pick up the par value, which will be equal to the 1,000. Then the market price, which is going to be equal to the 1,300. Underlining that, font group and underline. That'll give us the subtotal. Subtotal is going to be the 1,000 minus the 1,300. We're going to take that and divide by the maturity in years. Years to maturity, whichever way you want to say it. I think it sounds better the second way. Home group, font, underline. And that's going to give us another subtotal. We'll just call it the subtotal. And that's going to be equal to the 300 divided by the 8. Adding some decimals there. Number group, couple decimals. Underline it, font group, and underline. That'll give us the num, or numerator. The num is going to be equal to, as it was before, the 110 divided by the 3750. And that's not what it's supposed to be. We're supposed to add these. Let's sum them up. Summing them up, adding a couple decimals, number group, couple decimals. There we have it. And this is where the new stuff happens down below, because now we're just going to add up the market price and the par value and divide it by 2 this time. That's the new thing that's happening. This is where the new stuff comes in. Pay attention here. This is where the new things are happening. So we'll add those up, equals the SUM. Underline here, font group and underline. We're going to divide that by 2. And then so we'll divide that by 2. So we'll take then this equals to 2,300 divided by 2. Let's put an underline underneath that 2. And that'll give us, once again, our approximate yield to maturity. Little less accurate approximation here, being the 7250 divided by that number we just got to, making that a percent. Number group percentifying, adding a couple decimals. We're at the 6.3 as opposed to the 6.14 we got to before, which is a darn close estimate because that's like right on to what we had in the actual number that we did with Excel.